All right, today we are going to start talking about our second transformation. The first transformation we just finished talking about was dilations. So remember, dilations are just similar figures where you're either reducing your original shape or you're enlarging your original shape. So the size of that shape was changing because it was an enlargement or a reduction. So we're going to talk about 4 different transformations. So the dilations was the first. Now we're going to talk about our translations as our second. All right, so let's go ahead and look and see what's happening with this. So first of all, we need to talk about what a translation is. So what a translation is when you're simply sliding or moving a figure. Something kind of a silly way to think about it. If you're translating from English to Spanish or from French to Spanish or just translating languages, you're translating it, but what you're saying is the same. It's just in a different language. So that's something to kind of think about. You're not changing the actual words. It's just in a different language. So translating, we're just sliding or moving that figure, sliding or moving from one language to another. It's kind of a silly way to think about it. So with a translation, this is going to be what we call preserves congruency. So when it preserves congruence, that means that the shape does not, should have capitalized both of those, does not change. Okay? So the size of the shape and the actual shape does not change. So I'm going to say size of shape does not change. Okay? The x-coordinates, just so we're going to talk about this, x-coordinates, in case you forgot, are from left to right. So the x-coordinates are going to move left or right. And the y-coordinates in an ordered pair are up and down, so those are going to move up or down. And this will make more sense once we see with the picture. So basically, whatever shape you have and you're translating, you're just moving it left, right, up, or down on the graph. But it's going to be the exact same shape and the exact same size of what you started with. So a dilation is the same shape but a different size. A translation is same shape, same size. So maybe we can write that to help us out. Same shape, same size. So same shape, same size, we're just moving it. Okay? Alright, so let's look at this with some examples. So the first one says translate the given units 3 units to the right. And what I like to do is I like to draw 3 and then my arrow to the right. Draw the translated image on the grid and label the vertices A prime, B prime, C prime, D prime. Then we're going to complete that table. So here's my original image because we don't have those apostrophes to represent prime. So we know this is my new image. So I'm going to start with A. If I'm going 3 to the right, that means I'm going to do this actually in a brighter color for us. I'm going to go 3 to the right. So I'm just going to go 1, 2, 3 to the right. And that's my new ordered pair for A. So A prime. Then B, 1, 2, 3 to the right, so that's B prime. Didn't tell me I was going up and down any, it just said going 3 units to the right. So D prime is going to be 1, 2, 3 units to the right of your original ordered pair for D. And then C prime, 1, 2, 3. And then we can connect these. Okay, so this shape has just been moved over. It's the same exact shape, this quadrilateral, same shape, just a different size. That's actually going to be a trapezoid because we have only 2 parallel lines that are the bases. So the original image, let's talk about that. A, B, C, and D. We're going to complete the table with the ordered pairs. And remember, X is left to right and Y is vertical. So horizontal, Y is up and down. Horizontal left to right, vertical up and down. So my original ordered pair for A, start at the origin, and we're going to go 1, 2, 3, 4 to the left. So that's negative 4. 1, 2, 3, 4, up 5. So that's positive 5. Okay? And if the units don't say if they're worth 2 or 3 or 8 or whatever, we're just going to assume that they're 1. So start back at the origin. We're going to go 1 to the right, so that's positive 1 for x. 1, 2, 3, 4, up 5. Then for C, start back at the origin again. 1, 2, 3 to the right. 1, 2, 3 down. So 3 to the right, 3 down. And then start back at the origin again. 1, 2, 3, 4 to the left. 1, 2, 3 down. So negative 4, negative 3. Okay? So my new image is with my apostrophe. So we can call this original image. Sometimes you'll hear it, they'll say pre-image. And then they'll say this one is image. So just so you know, if they don't say original image or new image, you might see the words pre-image, which means the original, and image just means the new. So something to think about. So now if we move 3 units to the right, let's see, negative 1 is my x. 1, 2, 3, 4, 5 up. So that's negative 1, 5. B prime is 1, 2, 3, 4, 5. I'm sorry, I think I went too much. 1, 2, 3, 4. Yeah, there we go. 4. 1, 2, 3, 4, 5. So 4, comma 5. Then go back at the origin again. 1, 2, 3, 4, 5, 6. 1, 2, 3 down. So positive 6, negative 3. Then D prime is 1 to the left. 1, 2, 3 down. 1 to the left and 3 down. So this is just showing you what the picture, what happened. So let's look and see. How did your x coordinates change? Well, my x coordinates are right here. Here, I'll circle them. That marker's dying. Let me use another one. Need to get some more markers. So let's think, how do you get from negative 4 to negative 1? And from 1 to 4? And from 3 to 6? And from negative 4 to negative 1? Well, our brains don't naturally work in negatives, so look at your positives. 1 plus 3 is 4. 3 plus 3 is 6. Negative 4 plus 3 is negative 1. And negative 4 plus 3 is negative 1. Okay, so our x coordinates change. X coordinates changed by increasing or adding 3 to the original x value or coordinate. Okay? That's why we moved right. Stop and think about it. When you're moving to the right, we say that's adding, it's plus. Okay, it doesn't matter if you're still here in the negatives, we still move to the right. So every time we move to the right, you're adding 3. Okay, well, did the y coordinates change? Let's look. 5, 5, 5, 5, negative 3, negative 3, negative 3, negative 3. So we can say y coordinates stayed the same. And if you think about it, that makes sense that they stayed the same because we were only moving to the right. If you're going to be moving up or down, then your y coordinates would have changed. And we can actually see that with the picture. Okay? So let's look and see what we're going to do next. It says, use the original answers from part A to write a generalization or a rule in XY form. So for example, when we did dilations, we said KX, KY. And if K was 8, that means your dilation was being, your scale factor was 8. We would say the rule for that one would be 8x, 8y. So your original image is just your original ordered pairs. And to get to my new image, we took your original x coordinate, we added 3, and my y stayed the same. So no matter what the x was, negative 4 plus 3 was negative 1. And your y stays the same. 1 plus 3 and your y stay the same. So the only thing that we changed in our new image was the x's. So that's how you're going to write the rule for this translation. Okay? Well, now what we said, trapezoid ABC is now translated 4 units to the left. Okay? Write a rule in the form, in XY form, to describe the translation. So you're always going to start your rule with XY, and then your new arrow, your arrow is going to say that you're translating or moving to this new image. Well, think about it. If you're moving 4 to the left, is that affecting your Y or your X? Left, right is always X. So we would take our original X and move 4 back, so we would subtract 4. And our Y stays the same in this one because we're not moving left or right, or excuse me, we're only moving left or right. We're not moving up and down. Okay? You can, even if you put a number in here and it makes sense for you, if you know your original X was 6 and I moved 4 to the left, 2, 3, 4, 5, 6, and I moved 4 to the left, 1, 2, 3, 4, you can see that your X value is 2. Okay? So anytime you're moving left or right, you're going to be adding or subtracting to the X. Anytime we move up or down, we should be changing our Y, since that's a vertical. And we'll show you that with these examples. So now it says, let's think about this. Explore the characteristics, the sides, the perimeter, etc. of the original image and the new image. How do they compare? We can even use this picture up here. Well, if this side length was here, and that's 1, 2, 3, 4, 5 units, and then we moved it, that's still 1, 2, 3, 4, 5 units. If it's staying the exact same size and the same shape, and it's not being dilated, then that means all those side lengths are the same. So we can say the sides, perimeter, area, and area of the original and new image are the same. Again, you can see it with the picture. They're going to be the exact same size because all we simply did was move the shape. Okay? They're the same dimensions. So we can say the sides, perimeter, and area of the original and new image are the same. We just moved the shape. The size of the shape stayed the same. Okay? Again, that makes sense because when it was a dilation, it changed the actual size, so then we had the perimeter and the area being changed. But if you're the exact same size and the exact same shape, just in a different position, just being moved over, you're going to have the same perimeter and area. All right, let's look at some more examples just to make sure you understand this before you try some on your own. So now this has the same trapezoid. So these are the same. This is the same trapezoid as before. So I'm just going to get our pre-image or our original image right here. Our ordered pairs, A, B, C, D. So this was the same trapezoid we started with. So we have a -4, 5, 1, 5 for my ordered pairs, 3, -3, -4, -3. So our new image, or you can also call it just the image if they use the word pre-image. Let's see what we're doing here. It says translate the given figure down 2 units. So if you're going down 2 units, is your X or your Y going to be affected? X goes left to right, Y goes up and down. So it looks like our Y's are going to be affected, and we'll show it with the picture. So it says draw the translated image on the grid and label the vertices A prime, B prime, C prime, and D prime, and complete the table. So here's my original ordered pair for A, which we've already done these ordered pairs on the table to the right. We're going to move 2 units down. So from here, 1, 2 units down is A prime. D prime, 1, 2 units down, D prime. B, 1, 2 units down, B prime. C, C, 2 units down, 1, 2, that's C prime. Make my trapezoid. So it's just slid down. Same size, same shape. So A prime, B prime, C prime, D prime. And hopefully you're already making predictions. So we can see right here, 1, 2, 3, 4 to the left. So my X is still -4, and my Y is now 1, 2, +3. My B is X is 1, and I go up 3 to get to that ordered pair for B prime. My C, 1, 2, 3, 1, 2, 3, 4, 5. Okay, and then my D prime, 1, 2, 3, 4 to the left, 1, 2, 3, 4, 5 down. So -4, -5. Okay, now it is important to say with translations, you could be changing both the X and the Y, but you're going to move one at a time. So if they said to go 2 units down, you could go 2 units down and then 3 to the right, 3 to the right. So you'd have to do that with all the ordered pairs. So with translations, just your X value could change, or just your Y, or both. Okay, so that's something we'll look at in just a minute, but just something to think about. So let's see what happens here. All right. It says, write a generalization rule in the form. Well, think about it. -4, -4, 1, 1, 3, 3, -4, -4. It makes sense that the X's changed because we were only moving down. We weren't moving left or right. Well, 5 minus 2 is 3. 5 minus 2 is 3. And anytime we're going down, that represents -2. Anytime we're going up, that represents positive. I shouldn't just say every time it's going down is -2, depending on how many units. -3 minus 2 is -5. -3 minus 2 is also -5. So from your original to your new, well, the original image were just the ordered pairs. We would say X, Y. So my X's stayed the same. My Y's, every Y value I had, I subtracted 2 to get to the new image, the new ordered pair. Okay, so let's look at some more. We're going to write these rules and then you'll have some practice on your own. So let's say this trapezoid is now translated 5 units up. Write a rule. So if you're going 5 units up, what's being changed? Your X's or your Y's. So I like to do that to help me out. If I'm going up, that only my Y's are changing. So my rule would be X, Y. So original to your new. X's stay the same. And if I'm going up, that means Y plus 5. So any ordered pair that you have, doesn't matter, we don't know these ordered pairs just yet, but once we know the ordered pairs, if this was a different trapezoid for A, B, C, D, we would keep all the original X's and all their Y values adding 5. Okay, so let's look at a little bit more before we get some independent practice for you. So it says triangles ABC has vertices of A, 1, 3, B, 3, 7, and C, 6, 2. Determine the vertices of A prime, B prime, C prime after each translation. So 4 units to the left. So first we're going to write our rule. X, Y is my original to my new. So if I'm going to the left, is my X's or my Y's going to be changing? Left to right are X's. And anytime I'm moving to the left, I'm going to subtract. So you have to be careful on these because sometimes if you do a trick, you'll fall for a trick answer. They could have done X, comma, Y minus 4. Or they could have done X plus 4, comma, Y. But remember, anytime you move to the left, it's going to be subtracting. Anytime you move to the right, it's going to be adding. Anytime you move up, it's going to be adding to the Y. Anytime you move down, it's going to be subtracting from the Y. So just think about what we've talked about already with our coordinate grids. So here's what we need to do. We're going to take our X's. Those are the only things going to be changed. Okay? So I just kind of circle that so I don't use the wrong numbers. So if I take 1 and put that there, 1 minus 4 is negative 3. My y stayed the same, so I just put the 3 down. Then b prime, well, my original x was 3, so 3 right here, put that in there. 3 minus 4 is negative 1, and your y stays the same. Okay? Then I go to c prime, and my x is 6, so if I put 6 right here in my rule, 6 minus 4 is 2, and my y stay the same. So in this situation, all of your y's were the exact same, and the only thing that changed is where your x is, because we're moving 4 to the left. We're translating or sliding our picture 4 to the left. Okay? All right, let's try one more together and then get you some practice. Now, we're not going from these ordered pairs. We're going to start from our original because it didn't say from the previous one, so that's something to be careful about. So if we're going 6 units to the right, so just read carefully, and 3 units down, we're going to write the rule, and we're going to go from there. Okay? So what I mean by that is if they were saying after you translated 4 units to the left, and then said from the previous translation, now you're doing that, we would use these ordered pairs. But we're kind of resetting, and we're going to go back to up here, okay? So let's see, my original ordered pairs, now I'm just going to write it above here since I kind of colored it up there. 1, 3, B was 3, 7, my original C was 6, 2. Okay, so first we're going to write the rule. So x, y, 2, my new image. Well, if I'm going 6 units to the right, anytime I move to the right on a number line, that represents addition. So x plus 6. And then if I'm going 3 units down, doesn't matter where I am, when I'm going down, that represents subtracting or negative. So y minus 3. Okay? So this is a translation where both your values can change. Again, with the translation, just the y's could change, just the x's, or both of them could. So let's look at our x's first. And I'll do different colors on this to help us out. So I'm going to put my x's in orange. So if my original x was 1, 1 plus 6 is 7. And then I'll underline my y's. My original y was 3, so 3 minus 3 is 0. So you're using this rule to help you out. Okay? So that's my new ordered pair for A prime. If I moved 6 units to the right and then 3 down, this is where I would land. Okay? Let's keep going. So now B is 3, so B prime, when x is 3, put that there, 3 plus 6 is 9. And my y is also changing by I'm going down 3, 7 minus 3 is 4. So instead of having to sit here and draw these pictures each time, now that we know how to write the rule, it makes it a little bit easier. If you still need to draw the picture to do that, that's okay too, but eventually you're going to understand how to use these rules. It's a lot faster to do this. So my rule, x plus 6, y minus 3. So if I have my ordered pair of 6 and I add 6, my new x is 12. 2 is my y, but I'm going to move that down 3. So I'm going to land at negative 1. Okay, so these are your ordered pairs. So we have to be responsible for not only writing the rule, depending on how they're translating, but also understanding the new ordered pairs, and also understanding that it preserves congruence. It's going to be the exact same size and the exact same shape. We're just relocating it on the grid. Okay? So again, rewind the video, rewatch it if you need to hear those things again, and ask your teachers if you need help as you're working on your independent practice.